So a number of people commented on my somewhat snide and maybe only 80% serious takedown of Marvin Minsky by saying, well, I'm sure it wasn't as dumb as you're making it out to be. But Amelia here is getting it right. She's saying, well, most CS students don't see math as being particularly important for their field. Now, I want to point out that pure theoretical computer science is actually an extremely mathematical field, but that is not the way most people who were doing AI back in the day before neural networks thought of math. I mean, I don't think Minsky was dumb, right? I'm not saying that he was dumb. I'm saying that even very smart people, if they don't put enough effort into understanding certain things, they're going to miss things that are actually fairly basic. I once had a math professor at Harvard. His name was Andrew Gleason. Best math professor I ever had, by the way, and he was teaching this incredibly difficult course. In order to even get into this course, you really had to go through a trial by fire because the problem sets he gave out were really, really hard. Now, he would like to talk to us as we rode up with him in the elevator to class in the mornings, and sometimes he would say these little pithy nuggets of wisdom. One of the things I really remember him saying to us in the elevator one day was, never underestimate the trivial. Having a grasp of these things that I'm calling obvious is more difficult than it seems. Even someone like Marvin Minsky, who I don't think was stupid by any means, didn't grasp these things, these basic things about multidimensional calculus. But it really is the case that this thing is very basic. So when it comes to back propagation, okay, I'm going to explain it a little bit more than I did in my video. What you're talking about with a multi-layer perceptron, or let's say a two-layer, even just a two-layer perceptron, is you have a perceptron and then another perceptron that takes the output of the previous one, okay? This is mathematically just a function composition. It means you're taking the first function, which is the first layer, and then you follow it up with another function, which is the second layer. The chain rule basically says that to compute the derivative of the combined composed function, all you need to do is take the derivative of the first function and multiply it by the derivative of the second. Now, this is something that everyone learns in high school, actually, if they take calculus. In the multidimensional case, it is not just a number times a number, it's a matrix times a matrix. And that is what back propagation is. And anyone who was paying attention in their multivariate calculus class would understand that intuitively. But AI folks did.